Hey everyone, you just watched a video and took some notes, so now we're going to do some practice problems. Let's start with number one. If you get stuck on number one, flip back and check your notes, and I'll see you in a minute. Great, you just finished solving number one. Now let's look through my work. So my first step was to choose a variable to isolate. So I chose the variable x. I moved my 3y to the right side of the equation, and I isolated x as being equal to negative 3y plus 3. My next step was to plug that value into equation b in place of the x. So I took that value for x, plugged it in here, and there we go. My third step was to solve for the first variable. So I first distributed my 2 through my parentheses. I had a negative 6y and a positive 5y. Negative 6y plus 5y gives me a negative y. I then subtracted 6 from both sides and divided by that negative 1 in front of the y to isolate my y and get my y as being equal to 1. My fourth step was to plug that value back in. So I chose this equation here, the x equals negative 3y plus 3 from above, because I thought that would be the easiest one to plug y back into. Y we said is equal to 1, so I plug that in here for y, do some math, and I find out that x is equal to 0. My solution then is 0 and 1. Okay, let's try number 2 now. Pause the video, solve out number 2, figure out what your solution is, and we'll come back together in a minute and I will walk through my steps. Great, so the first thing I did was I chose a variable to isolate. I chose the variable x. I chose x because there was no coefficient in front of the x, so I knew that would be the easiest one to isolate. I isolated x by moving 5y, subtracting 5y from both sides, and I found that my x is equal to negative 5y minus 9. Step 2 is to plug that value in for x in our other equation. I did that here. That value for x goes in place of x, and then from there we can solve for the first variable. A little distribution here, some math combining like terms, combining my negative 20y and my positive 3y, and when I do all the math out, you find that y is equal to negative 2. Now that we've solved for the first variable, we can plug it back in. I chose the simplest one, which was x equals negative 5y minus 9, and plugged in that negative 2 in place of y. Negative 5 times negative 2 is positive 10, minus 9, and we find that our x value is 1, so my solution then is 1, negative 2. X equals 1 and y equals negative 2. Great, now try number 3. Solve it out, and we'll come back together in a minute to walk through how I solved it. Great. So your first step and my first step was to choose a variable to isolate. We already have the y isolated in this second equation, so I'm going to use that, y equals 1/2 x minus 3. Our second step is to plug that new value into the other equation so that that new y value 1/2 x minus 3 goes in place of the y in our other equation. So that now becomes this whole thing right here. Then we're going to solve for the first variable, which is x. I distribute my 4. I add 12 to both sides. And I actually find something really interesting, which is that 0, x equals 0, 0 equals 0. And that suggests to me, since I can't solve that out, that this system of equations actually has infinite solutions. And we can actually prove that out another way. Let's take that first equation again, which was 4y minus 2x is equal to negative 12. That was the first part of our system. So let's break that down and move that around and create an equivalent equation. So I add 2x to both sides, which gives me this. Divide both sides by that 4. And I get y equals 1/2 x minus 3, which is exactly equivalent to our second equation from the original system, which was also y equals 1/2 x minus 3. And as we know, if we have a system where we have two lines that are exactly overlapping each other, that system of equation will have infinite solutions. Now try number 4. Okay, I think we're getting this. I'm going to show you my work. I'm not going to walk through it step by step, but I want to show you what I got so you can check your answer. I found the solution to the system to be -3, -2. Take a minute now and look through my work if you weren't able to get that solution. Now try number 5. Okay, here is my work for number 5. After solving out this system of equations, I got 4, -1. Pause now, take a look at my work, and check it against yours. Now try number 6. With number 6, I chose to isolate y as my variable because I already had it set up as y equals x plus 6. I then plug that into the other equation. This takes the place of y. And when I distribute and solve for that first variable, I find something a little interesting. On the left side, after I subtract my 2x's from both sides, I find that on the left side of the equation I have 4, and on the right side 0. Those don't equal each other. And so that suggests to me that this system of equation has no solution. And we remember what a graph of no solution looks like: a set of parallel lines.